This is a super fast introduction to our STEPScope TDR analyzer. There are a collection of other videos that you'll want to watch to learn about some of the other specific details, but I thought we'd start by doing just a quick introduction to the STEPScope. And maybe to start there, I'm going to visit our website and take a look at our STEPScope TDR, because I'd like to take a look at the block diagram of what's inside the STEPScope. The STEPScope itself has in it a pulsar that generates super fast edges and a sampler that can measure the time domain view of those edges according to a time base that's in it. The pulsar's edge signal will come out, head down through your device under test. Any imperfection in that impedance might cause a reflection of some energy back into the STEPScope, in which it's measured in the sampler. What I just described is what's called a reflection measurement, TDR, time domain reflection. Another measurement that's commonly done with these devices is a transmission measurement. In a transmission measurement, you would have a separate pulsar, which could be another STEPScope, or it could be one of our remote pulsars, and it generates a super fast edge that then comes into the receiving STEPScope, bypassing the internal pulsar, but it makes its way into the sampler so that I can measure. And that's used for making transmission measurements, time domain transmission, TDT, but is also used for making return loss measurements. Insertion loss measurements, where you're looking at it in the frequency domain. Our STEPScopes include in them a complete Linux operating system, and I just thought I'd point out that on the back of the unit here you have keyboard, mouse, and a HDMI port over here, and you can completely drive a Unix workstation from this, but by far most customers will simply put a network connection in and run it through a web browser. The browser, it supports all types of browsers. You can even run it from your phone, but you simply have to address the device itself. For example, here I have a browser up and running. Let's see which one here, the STEPScope. And here I'll give you a quick overview of the browser itself. The browser includes a collection of features that you can look at. The information panel, for example, a step response view, time domain reflection, time domain transmission, and then two optional features, the S11, which is return loss, and S211, which is insertion loss. These views let you see the graphical data. We'll make a measurement here in a second, but the other thing that you have on the interface are a collection of some tools that are sort of universal or used for all the different analyzers you have. For example, the run status will let you know if you're running or stopping, or you can run for certain durations. We have calibrations that are platform calibrations, so you can calibrate the noise system or the delay system that's on it. Those are just done routinely, I don't know, monthly or every 6 months or so. We have general purpose IOs out the front of the box. Those are just voltage sources that you can control if you need to provide a bias circuit, for example. It's nice because you have remote control access to it, and you can turn things on at higher or lower voltages. And then most importantly, it's the pulsar. And the pulsar is the device that you can control what amplitude and what frequency you want to pulse. We'll go into more detail on that in a future video. But you also have a few different pulsing modes. The local pulsar is when I'm the pulsar. This STEPScope is pulsing to itself. Remote pulsar is when you want to control a separate STEPScope to become the pulsar into this device. That's for when you're doing a TDT measurement. Triggered is when you are the second device in a two STEPScope application for time domain transmission. And finally, accessory. Accessory is when you're using one of our remote pulsars, and in which case you get the GUI for that device right here in the panel as well. So that's a quick introduction to the interface. let's take a look at one of these views, for example, the step response view. All of our views have access to tools and configuration settings for the view. Panning, zooming, cursors are all supported. For example, if I go back and look at the instrument I have here, I am going to use this in a single-ended mode, but for example, if I use my termination kit and I put on a second termination, so both of my outputs are now terminated to good-looking signals there. And if I run and align my step response view to looking at the full square wave here, 0, 1, 0, 1, I can see this is my pulsar being sampled by my device. This is the square wave going up. This is the going down for the duration of the pulse. And then we have the similar negative pulse. You can actually make measurements for reflections on either positive edges or negative edges. There's a very slight difference between the two edge rates. I also have the ability here to go in and, for example, look at, let's say, the rising edge. And that will zoom in on just the rising edge of this. If I use my cursors here, I can right-click and zoom in on this, and I let go, and it will make a new measurement. And when it made the new measurement, it would assign the number of points you have between the left spot and the right spot of the view you're looking at. I can change this number of measurements here. If I want to do, I don't know, 300 measurements instead of 1,000, it comes up even faster. I can have that go up to many, for example, 16,000 measurements, and you'll see it'll make that measurement, but this will take longer. And so we'll do another video that'll go through how you might optimize to make the fastest measurements you want. Clearly making 16,000 measurements in 109 picoseconds of time, you've got a lot of redundancy in there. So let's go back to 1,024 measurements, 1024, and it'll make a new measurement. Now, cursors, I can bring up cursors here on all my graphs. I can fit the cursors to the screen. For example, if I measure that amplitude right here, I see that's about, let's call that 800 millivolts. If I wanted to come find the 1090 points on here, that would be 640 millivolts. Let me find 640 millivolts or so. I'm going to position those cursors. I'm going to move this cursor here and there to look at about the 1090 rise time, 17.4 picoseconds inside the instrument. So that gives you a feel for the bandwidth inside the sampler and the pulsar inside the device when making TDR measurements. That's not the same edge as you get outside the machine. Outside the unit, we specify 20 picoseconds, 1090. It's a little bit faster than that, but that's with any kind of losses. You would then also have losses of your system when doing reflection measurements or transmission measurements as well. Back to the full square wave. A graph like this, as all our graphs have, also supports the ability to do some downloading and auto-aligning. For example, this download button in this particular view, step response, will give us a small pop-up window, much like you'd expect for any kind of browser. I can click on that and open up the file that was downloaded. In this case, it was a CSV file that's used for displaying the actual data, the raw data. I might bring that over here so we can see that there's just an ASCII listing of the values, the picoseconds and the millivolts that were measured in each time. So the data doesn't stop with this instrument on any of the graphs. You can take the data from here and use it in your system. The subjects that are handled in the next videos, but this gives you a introduction into the primary engine that runs the STEPScope, the ability to measure very fine at high bandwidths noise-free waveforms like this.